Guys. Guys. As we get into this basic part of this week, is we're going to be talking a lot about what are called triangle proofs. And triangle proofs take a little bit of getting used to, and how I don't say the vocabulary, but how the wording works with it, and how the setup works and all that. But it all stems from the information that you have at your fingertips as far as the progression sheets are concerned. Those are kind of the roadmap of telling you how things work, okay? Last week when we were working, we had talked about that in order to show that two figures were congruent. Really? Don't. Yes. We were saying that two figures were congruent if all the parts were congruent. We talked a little bit about triangles. When we looked at triangles, that meant that you had to have all three angles and all three sides. Well, what happens really is that we start to peel back some of those layers of having to show so much being congruent, where you only have to have specific portions of triangles. Bless you. And one of the things that we look at we start talking about what's called like the alphabet soup of congruences. And there's going to be a bunch of them. We've got side, 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 angle, side, angle, 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 side, hypotenuse, like, so there's 4 or 5 of them that we look at as we go through. And what that means is that instead of having to show all 6 pieces, today we'll start by looking at what's called if. If the 3 corresponding sides are congruent. If you have 3 sides that are congruent to each other, then you know the triangles are congruent. Okay? We're going to talk about that. That right there, bless you, that is called side, side, side. Instead of having all 3 sides and all 3 angles, if you just have the 3 sides congruent, then you can say the 2 triangles. Here's what it says. If the 3 sides of one triangle are congruent to the 3 corresponding sides of another, the triangles are congruent. Basically, it's this. And then we say it's called bi. We use the lettering side, 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 S, S, S. Now, in your notes, I would make sure that I have a picture of what it looks like and what it's labeled. Side, side, side. And, excuse me, as we get into our progressions, our sheets, what I would do is take one of our sheets or one of our squares that's not near everything right now, maybe like on yours, the bottom right corner. I'm assuming most of you guys don't have anything written on the bottom right. Most of you guys kind of go start at the top, work your way around. Go to the bottom right corner. And what I want to do here is I'm going to start making a little list. And I'm going to put in my square. Works. I'm going to put in that square. And I'm going to not like put a ton of it in there right now. I'm going to make a little note to myself. And I'm going to put in the header here to show triangles congruent. I'm going to put that in that lower right-hand corner, away from everything else, because it's going to be ways that we're going to show. And today, the first 2 we're going to look at is this. It's called side, side, side. And then I want to put a little diagram of what that looks like. So you know what to look for. Look for them for side being congruent. Okay. So basically what we're looking at is if we can show that we have 3 sides that are congruent from one triangle to another, we can then say the 2 triangles themselves are congruent. It's taken not having to show all 6 pieces. And that's kind of what we're getting at. We're starting to peel back some of the information. Now, ways that this is going to happen, Well, it depends, again, back on what information you start with. Okay. What I mean by that is, if you go back and look at your progression sheet real quick, start thinking about what we know in terms of segments. We have stuff on there about midpoint. We have stuff on there about segment bisector. We have bits of information that we're able to get from to show things are congruent to one another. And that's the idea of being able to use specific information from one diagram to show that something happens. Bless you. For example, let's do this two-column proof. Okay. We have a given and a proof statement and a diagram. And what I want to do is walk you through how we set it up, how we write it out. Well, good morning. All right, so write out our congruency stuff. You don't have to put the bars over the segments and whatnot. That's what we're just looking to go through. Yes, ma'am. This is your notes. We'll come back to those here in a little bit. Is this one you might write down? What's that? No. This is an actual two-column proof. We haven't done this for a while since we've done the algebra stuff. This is going back to doing this. So what I want to do is draw out what we have, and then we're going to do this as that statement reason thing. Okay? So if you need paper, I've got plenty of paper. Ladies and gentlemen, you have to be able to write this stuff down and be able to do this. Excuse me. So as we go through, you'll notice that the diagrams are either marked. You have LM congruent to NP, LP is congruent to NM. So here's what you do. We write down what we're given. Why did I write that down? What's the reason that I wrote it down? Because it's given. Okay, can I do anything besides make sure the diagrams are marked? Nope, diagrams marked. Go to the next one. Again, it's given. It's marked. Now, we need to get all three sides congruent to each other. You'll notice you've got two triangles, and those two triangles have a shared side, don't they? What side do they share? They share LN. Now, way back a long time ago, when we did algebra stuff, one of the things that we talked about on that white sheet of paper that said the reason bank to it was something called reflexive property. The reflexive property states that you are yourself. So a lot of times in triangles, you're always going to see this, what's called an overlap side, a side that's shared between two pictures, or two triangles, two shapes. This side is shared, and aren't you always congruent to yourself? So what that means is that we are using what's called the reflexive property to say that it's congruent to itself. Now, before we go any further here, do this. Go back to your squares. And I'm going to put in a note. Look for shared side.
In the same box?
New one. Bless you. What I'm saying here is look for a shared side. And here's what I would do. I would draw a little diagram. It don't matter. It doesn't matter at all. Because I'm just using a rough example. Because what's the shared side here? Everybody see how AC is shared between the two triangles? So I know that that is shared between the two, and they're sharing the same thing. That side will always be congruent to itself. So what I would do in a proof is this. Statement, reason. AC, congruent, AC, and the reason is reflexive property. Reflects And that's going to be what we do a lot of. We're looking for what's called a shared side. That shared side is called the reflexive property. You can, remember how we talked about inferring things from diagrams? Remember how we inferred vertical angles, linear pairs, things that make a line, things like that? Reflexive property is one of those things that you can take from a diagram and not have to worry about, because it's shared between the two figures. So back to the proof we were just doing, that shared side would be, what is that, Ln? So in my proof, I would write Ln is congruent to Ln. Reflexive property, exactly. Okay. So going back to there, I know that Ln is congruent to Ln. Yes, sir? No. Do you have all three sides congruent to each other? You do. That means now our triangles are congruent because you've got all three corresponding sides. Triangle LMN, NPL, side, side, side. That's what it means to walk through a proof. You are given specific information to start with. More often than not, you have to come up with one extra step on your own and write it out. A lot of times people freak out when they start seeing proofs because they get really worried about not knowing where to start. You always start with your givens. You always then mark your diagrams, and then you just look and see if there was a definition that you could use. In this case, there wasn't a definition, but what we were able to look at is we were able to infer the fact that you had a reflexive property being used. And that's how you get all three sides. Okay? So, yes, sir, we have side, side, side. And the next one we'll look at today, well, actually, I'm trying to think about another one of these real quick before we go too far. Yeah, that's the same thing. Let's do this. The other one we talk about this is a little bit different. Instead of having just the three sides congruent, sometimes you can have two sides and what's called an included angle. Included angle means the angle between the two sides. If you have two sides and the angle between them congruent, you get the two triangles are congruent. And the reason for this would be side, angle, side. So another one that you can put on that box of ways of showing how it works is called side, angle, side. And again, it's the side and angle and a side, the side and angle and a side. It's the angle in between the two sides that are congruent. That's called an included angle. It's called an included angle.
And if you guys just look at that notation, side, angle, side, you can see that A is in between the two S's.
And that's the whole idea of using the abbreviations like that to make these things work. It's a lot cleaner for most of the information. Excuse me. So the other way that we're going to look at this is we'll have a pair of sides and the angle in between. All right. Not terrible? Not terrible. All right. Let's look at an example of how this might play out. Oh, actually, we just did one like that. Let's do something with. Let's do something with something that we'll have to use off of our progression sheet. So go ahead and write this up, draw your diagram, and we'll see what we can figure out. You're going to be using that as you go back and forth. When whenever we do proofs, you're going to want to have that sheet next to you because it helps you figure out the steps. Now, in this one here, you've got a given of a couple of segments, and you're also given a midpoint. Guys, look at your progression sheet, and you should have some information on it about a midpoint. I think it was one of the first ones that we did. It said if you were given a midpoint, when you say that, you know you have a midpoint. That's what happened. No, what's the progression sheet say? Exactly. So let's see how this plays out. Let's see how this will work itself out. So we have the statements and reasons. Given. In this case here, is there anything I can do with that given statement besides just mark the diagram?
No. But yes.
There's nothing else to do besides mark the diagram in this case. When that happens, you go to just your next given statement. You've used everything you can out of it. All I can do is just mark it. Next one says that D is the midpoint of AC. This is where looking at a progression sheet tells you exactly what to do next. There should never be any, I don't know what to do, because it's all on this piece of paper. On this piece of paper, it states, if given a midpoint, then segment convert to segment. For example, A is the midpoint of XY, given. AX is converted to X, or AY. Reason? Definition of a midpoint. So I know my little roadmap here is telling me exactly what to do now. Aside from the letterings being different, obviously. But if I know that I have a midpoint, it means that two segments are going to be equal to each other, congruent to each other. In our example, it would have to be those two. So what do you write down then? Well, you write down exactly what the definition tells you. Well, AD is congruent to DC. And the reason would be, well, what did you just use? The definition of a midpoint. That's how we use these progression sheets to get ourselves through the proofs. That's how these things work. You have a definition, you use the definition in your next step. Okay? Now what else can I say? Why? Very good, Josh, very good. Everybody notice that? Now you've got two sides, but we know that this one's shared, so we can say that it's congruent to itself. What's that, Josh? I'm sorry, I didn't hear all that. No, there's a lot of stuff to this. You got to be, when you're doing the proof stuff, you have to be extremely, what do you call it? Literal. You can't skip stuff. Okay. And then do I have the two triangles congruent? Huh? Look at the diagram, how they all marked up. All the sides, very good. All the sides are. So then ABD. And notice I'm not making up letters. I'm not changing any of the orders around. I am doing exactly what it says in the proof. I'm also using the symbol for a triangle. Remember how we did that last week? I said you got to use symbols for triangles, you got to use symbols for angles. I wouldn't worry so much about writing down, segment stuff. Are you going to write any of this down? Be a good idea. Okay, yeah, but this is a whole other thing. Okay, let's try again. Same idea. Sometimes we're going to be given extra information. Yes, sir. Yes. Always write down your given, draw your picture, and then start thinking about what can you do from the given information. What statements can you come up with after you were given something? I'll write out the given, let's write out our diagram, what's all we have. Excuse me. Notice, we're going back to the again where we have midpoints. And to be honest with you guys, most of the proof stuff that we start out with, especially this week, it's just going to be midpoints, perpendicular, angle bisectors, or segment bisectors. There's not much other stuff to it. I'm thinking about doing a short quiz on some of the proof stuff on Friday, but we'll get when we get to it. I didn't get a chance to rewrite it. Okay. So as we go through, we go to our first given statement. Statement, reasons. B is midpoint of AE. Yeah. In my diagram, I don't go right to the next given statement yet, Josh. What I always do is go to the diagram and see what can I do to my diagram knowing that I have a midpoint. Well, midpoint creates two congruent segments. Well, if it's on AE, what are the two segments that are made? AB and BE. Stop. Which means I write that down. AB congruent to BE. Again, the reason is definition of a midpoint. I was given a midpoint. I wrote what it did. The reason I wrote it is because that looks like seriously, stop it. You want to keep mouthing off to me, or there's the door. I'll send you right back to your brother. I asked you just to stop. I didn't say anything else to you. I asked you to stop. Go to the next part. I've already used up everything in that given statement, and I went through it. Next thing says, B is the midpoint of CD. So you write it down. Excuse me. If that's the midpoint now, go to the diagram. What two segments are created, or excuse me, are congruent? Go back. I marked it. Write it down. Again, what did you use? The definition of a midpoint. Now you have to figure out what your last step is. Quite honestly, everything to this point is all on that progression sheet. You didn't have to think of anything. All you had to do was just follow the directions. Yes, ma'am?
Is it okay for
Yeah, that's fine. Yeah, I'm not a big stickler on the lettering. As long as you get those two segments, it's fine. Okay. What she's asking, guys, she wrote it as CV, BD. The lettering, as long as the segments are congruent, it's fine. Can you infer that from anything? Is there anything on there that tells us that? Nope, there's nothing you can do about that. Which means you have to start thinking about other examples that you have. If you look at your progression sheet, you have a diagram that looks very, very similar to this. And it has something to do with the angles around B. What do I know about those? They're vertical. They're congruent, aren't they? On your progression sheet, you should have a thing that says look for vertical angles. Oh, you do. Look for them. Found them. I know that those are vertical angles. What do we know about vertical angles? They're congruent. So what I would write out then is the angles. Well, A, B, D. I go back to the other letter. I started at A, B, D. It has to be E, DC. And the reason is, on your progression sheet, vertical angles are congruent. That's what it says on the sheet. That's exactly what you're right. Vert angles congruent. Now, one of the things I want you guys to start picking up on, we have 3 parts that are already congruent on one triangle and 3 parts that are congruent on the other triangle. Look at how it's written out. I have 2 sides and an angle. Is that angle between the 2 sides? I have 2 sides and an angle. Is the angle between the 2 sides? Okay. Are the triangles then congruent? Okay. They're congruent because of side, angle, side. Again, all you had to be able to figure out here on your own was the look for vertical angles part. Yes, sir.
Those, if this, I wouldn't know when they're doing it. I wouldn't know when they're doing it. Doesn't mean they're exact same. But that means that no one would have to add it to the same value.
What do you mean by add up? Like
Because
angles? Yeah, angles are always going to have to 180. Yeah, but are you talking about?
That's congruent. And then that's they're both the exact same triangle.
Mhm.
There's one that's the exact same. I was just saying. So then if would those two be the same too?
Yeah, Josh, you're right. And so this is actually a shortcut. In the previous section, we had to prove all corresponding parts and angles are congruent to say the pieces are, or the shapes are congruent. This is a shortcut. If you can prove that 2 sides are the same and the included angle is the same, you could stop there. You don't have to prove the other ones, but yes, you are right. And the other angles will match up and so will the
So what
side.
about AD?
They would also be the same. There's a whole other reason for that later. We'll get to that next week. Did you get that? And the idea here is, guys, that you wind up with one of 2 ways of doing it for today. You get that side, 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 or a side angle side. And again, honestly, the only thing you had to come up with on your own here, if you're looking at this, was the fact that you had vertical angles that you had to pick up. If you picked up on those, everything else fell into place. Okay? The midpoint stuff, that was all on your sheet. It told you specifically what to do. You didn't have to think about any of that. It told you what to do and when to do it. It's nice. Okay? So that's what we're looking at here. We're not ready to do parallel lines with them yet, so. Oops. Got out of order here. Do this one. Take a minute, do this one. Please and thank you. Josh just said that. What's the only thing you have to come up with on your own? And what's the reason behind that? Exactly. That's what you're looking at doing here, guys. To be honest with you, as we start most of these things out, there's really only going to be one real step you have to get up on your own. JLM, marked. And then those 2, or excuse me, that would be congruent to itself. And again, the reason that's congruent to itself is reflexive property. What's the reason the 2 triangles are now congruent? The side, side, side. Yep. That's what we're looking at. Most of the things that we have over the course of this first few days, some people freak out. They're not sure how many steps they're supposed to have. There's really no set number of steps that you're always going to have. Sometimes you'll have, in this case, 4 steps. Sometimes you'll have 8 steps. It really depends upon the diagrams and the information that they give you. For example, if you look on your progression sheet, I think we talked about one where we had perpendicular. If you had perpendicular, then you had two things you could say about it right away. You're given that you had perpendicular, then you would say the right angles that were formed, then you would say that the right angles were congruent to each other. So it is super fast to wind up with a long proof because of some of the reasons you have to use it. Not that's equiangular. Perpendicular is when they turn 90. It's perfect. I'm sorry, I couldn't hear it. What was that? And it's yes, there are certain things you can get credit for, but what happens with proof stuff, if you follow the sequence that they give you, especially and use that progression sheet that's next to you, it's very hard to not get everything because it's all that's there except for usually one piece. And that one piece is usually reflexive or vertical angles or it's usually one of those two, to be honest with you. It's something that you're not going to be able to, it's hard to miss, okay? So that's why you just take a step back as you're writing them out, try to make sure you know exactly where you're going. Always draw pictures, always mark diagrams, and go off of that. Excuse me. Let's do that one then. Let's say we have let's try this. Given yeah, I'm going to walk you through a perpendicular one real quick. Oops. Ladies and gentlemen, let's walk through it. If you have your progression sheets out, you should have something on there that talks about perpendicular. There should be something on there that talks about perpendicular. If I'm not mistaken, what it says about perpendicular, it says first thing is to obviously put your given down, but then it says to state the right angles that are formed. Okay? So let's go through this and walk it through. BD perpendicular to AC, given. Now, looking at my progression sheet, make sure when we're writing these things out, guys, that you're actually going back and looking at your sheet so you know where to find it, because you've seen these a lot. It says to state the two right angles that are formed, or state the right angles that are formed. In this case, the two right angles are going to be ADB and CDB. So what I do is angle ADB and angle CDB are right angles. Okay? Because that's what it says to do on my sheet. Sir?
Okay, if that's angle ADB, what about that angle that was open across from angle A?
I'm not talking about those.
I know, but I'm just saying, like, how would you like what angle would that be? Would it still be ABB or would it be
I'm not worried about that right now. Okay. Well, you ask that later. Let me get through this first. Okay. What's the reason on your progression sheet that tells you that you can write that down? What does it say on your sheet though? Definition perpendicular. So that's what you write. Definition. See what I mean by using that progression sheet to get you through the whole thing? The next thing says to state that those two right angles are the same. So you just write it out. Reason? All right angles are congruent. Again, I am just writing down verbatim off of the progression sheet. I didn't have to come up with any of this on my own. It told me what to do. I have now completely done everything I can for the perpendicular, so then I go to my next given statement. That's the other reason why I don't write down all my givens at once. I try to use it, write what we can, then go to the next piece, and it said that AD was congruent to, what I write it as, DC. What's left to say?
These AD is congruent.
No. Oh, wait. What's left to say? What? How? You're skipping something. I only have one side and one angle.
Oh wait.
Someone just said it. It's reflexive. I have to state the reflexive side. You probably already marked it in the diagram because you saw it, but you have to write it down. You can't just say, oh, there it is. You have to say BB. Again, that was the only thing that you had to come up with on your own. Everything else is written out for you. And honestly, we have a picture of what that looks like on our sheet anyway, so you shouldn't have to ever worry about it. Now you've got your triangles, and you can say because of side angle side. And you're done. Okay? What's up? Yeah. Okay. I'd like you guys, I think I have 4 very straightforward ones we can try tonight.
4. Merge. Get off the phone, John.
Let's do those 4 for tonight. They're 4 proofs. Okay? You will find out that there's nothing on those 4 that we have not talked or tried yet.
Okay, this is how we have it. The work is showing off what
Yeah. You have to show your work to do this. You can't just say it. There's no way around that one.
this is like the one.